Let's go ahead and get started. Rao, are you ready for a technical update?
Yes, I am. I put the link to the technical update in the chat. I'm going to share my screen. I think everybody should be seeing community update 114 right now. So the technical update is kind of relatively light in that we have the 0924 that was released last week that is still running on the testnet. Mainnet continues to run 0923. And most of the items basically are status quo, but I'll speak to them in a little bit more detail. So the current, the development is going on slow and steady. NotZipper is working on making configuration changes to make node deployments easier and cleaner. Initially, we thought maybe he would be able to demo today, but we'll take some more time to clean it up. Also, he's writing tests to make sure everything is working as it needs to. So once that's all done, then we'll do a demo at some point in the near future. One of the major chunks of work that's going on is improvements to the last finalized state. There has been a draft PR for about a week or so now, but there is a lot of work there that's being done by the team. I don't think I spoke in any detail last week about really what this is about, what this is going to enable. So one of the issues, if you are trying to run the node right now, you'll notice that the catch-up of the node is taking a while. So that's one of the problems that this PR is going to solve, because instead of going back all the way to the genesis, you could just start from the most recently finalized state and then go from there. And this is something that is unique to RChain. Others don't have it as far as we know. And the thing this also enables is that it enables a validator to offload older data and create different storage strategies, different retrieval mechanisms based on the recency, currency of the data, and so on and so forth. So it gives them a lot of flexibility in terms of how they want to structure their services, as well as making the node leaner and less bloated. So those are the main things that this particular PR accomplishes, and there's still quite a bit of work to be done there. On the APIs front, one of the new requirements we got from an exchange was to have a Node.js API. So we're creating that, and we'll probably have a PR for review in the next couple of days. So then it'll go through the normal review and fixing the PR process, and we'll have that released at some point. Gurinder is working on augmenting and rationalizing how we're monitoring the different networks, mainnet being the main focus, but also the testnet, the sandbox network. So one of the things he's trying to do is to distribute the monitoring across multiple cloud providers so that we don't have, if we're running the nodes on Google Cloud, and if they have problems or if they go down, the monitoring does not go down, but we're still able to find out what's going on from a monitoring perspective. The team is attempting to expand the development capabilities, try to bring in outsiders into the development team, given the lean resource situation that we have right now. So in addition to all the hard work they're doing with the development, they're also teaming up to create some teach outs and short videos to enable people that perhaps have some development background, but maybe relative newbies to Scala, or somebody maybe just starting out to their career in the world of development, or senior Scala people. So anybody. So we're just going to look at different kinds of people that may be able to take on to or learn some aspect of the system, whether it is the core development side or the dApp development, and contribute to the core platform as well as the ecosystem of dApps. So that activity, essentially building and expanding the developer ecosystem, we're trying to do in the context of the current lean resource environment that we have. So those are the main activities going on from a development standpoint. And I listed there a bunch of backlog items that we will get to once we are past this last finalized state, once that's complete. But I kind of briefly talked to them last time, so I won't belabor that right now. So that's my summary on the tech update. Does anybody have any questions or comments? Oh, I do want to mention a couple things more. These teach outs or learning sessions, we're starting on Tuesdays with the wallet and dApp sessions initially. We're using them also as learning sessions. And then on Thursdays, there is the tech governance that which is not a teach out or anything like that, but that it's more of a forum where we decide the process for prioritizing and or how do we manage releases, how do we manage new features, that kind of a thing. So that's, the Thursday is a different thing from the teach outs, but we're starting teach outs on Tuesdays right now. Any questions or comments?
That was a particularly lucid accounting of the last finalized state. I really appreciate that. Yeah, people should really think hard about what this means. One example of the consequence is that a validator can use it to compact its own state. So the validators, as they're running along, the state that they're storing gets larger and larger. But if they simply export the last finalized state, pick up from there, then the state that they've got stored can be squirreled away for retrieval of, like you need audits or anything like that. But what it allows us to compliance with GDPR, for example. So we can forget state, simply go to the last finalized state. So that's a design feature that we've been contemplating since 2016 or 2017. It also allows for the validators to not hold on to so much and keep their operational down. So this feature alone is distinguishing for RChain because it both allows for compliance and allows for a better operational profile of cost and overhead. So let me just double check and make sure people understand what I'm saying. Does that make sense to folks? Does silence mean yes or no?
Thank you for the explanation, Greg. We appreciate it.
Oh, all right, sounds good. So moving on, there are a few items. So some people may have noticed the announcements from KuCoin. We're still in the midst of discussions with them, but there has been a kerfuffle around the fact that we hold Rev as a trademark. And there's another project that wants to list on KuCoin that has wants to use Rev. It appears that KuCoin was never clued in, despite our many messages to them, that RChain would, when it swapped, the token would go from ROC to Rev. You can see this in our private communications with them, and you can see this in their recent announcement calling the token mainnet ROC, which we've never used as a term and have always used Rev. So hopefully we can address the matter in an equitable and friendly fashion. But the board issued so there was a board meeting yesterday, and the board issued a resolution that it will take any and all steps necessary to protect our trademark. So hopefully, we have reason prevails in this particular case. Any questions on that? Okay. Moving on, there was a request from one of our members to ask, to describe our space in Rolang and what sets it apart, what sets us apart from, say, Ethereum and others. So I have addressed that in multiple talks and multiple documents. One of the documents that I think people should use in order to get a fairly straightforward explanation is the prospectus. So I'm going to paste a link here and in Discord. It's been pasted before, but it's useful, and I'll bring up the sections that are worth taking a look at, and share those on screen, and then yeah, paste the link. So hang on one second, I'll grab the link. All right, so all right, so here's the link. Huh. I don't seem to be able to paste the link. Raul, perhaps you could share that out.
We see that in the chat.
Do you see it? But that's from me to you privately. I'm not sure that.
Oh, okay, yeah.
Okay.
So did you want me to share that with the whole group, or is that what you
Yes,
want?
please. Yes, please. And I will,
Try again.
I'll also put it in Discord.
So I put it in there now in the chat.
Awesome.
Everybody should have it.
And I'm also putting it in, I'll just drop it into marketing since people are interested in communicating that. So there's the prospectus, which is the, something I posted in the marketing channel in Discord. And now let me go back and I'll walk through this sections. And screen share. Hang on, let's see. Okay. So I can do a screen share here. Okay, So let me see if hopefully that's big enough. So RSpace and Rolang need to be taken together. And I'll explain why. So maybe many people who are not in tech are unfamiliar with the fact that the last 15 years have been quite interesting for those technologists who are interested in storage. In particular, there was a big push around what's called NoSQL, which was a shift in the way to think about storage. Relational databases have been dominant for a very long time, in both in terms of the query semantics, and because of the query semantics, the ability to figure out when you can run certain things in parallel. But with Google, they began looking at a new architecture called MapReduce that was not based on the relational model and was enabling them to approach fairly large data sets that at speeds that they couldn't get their relational stores to match. Now, there's some interesting points here, which is that the MapReduce did not have a well-defined, the MapReduce paradigm, as Google published it, did not have a well-defined query semantics. A lot of people began looking at providing a NoSQL kind of store. So MongoDB is an example, Cassandra is an example. There are lots and lots of examples of these new kinds of stores. Of course, along with some of the performance gains for certain kinds of data sets, there were some trade-offs. In particular, there wasn't a crisp and clear transactional model, and there wasn't a crisp and clear query semantics. So what RChain does is it provides those things in a setting where we have absolutely crystal clear notions of sort of what NoSQL means and how that turns into a transactional account, and how that meshes with a query language. And so now you ask, well, what is that query language? And Rolang is that query language. Whenever you do a for comprehension in Rolang, the pattern matching part of the for comprehension is exactly the query language. What's different about it is that rather than having Keebler elves behind the scenes figure out some possible concurrency execution, the programmer states explicitly in terms of language constructs what the concurrency semantics are. So that gives the programmer a lot more control and a much greater ability to profile and hone their use of their data, their query of their data, those sorts of things. So essentially, it's a significant update on the insights from Google in terms of what NoSQL is all about. So it sort of provides a reconciliation of the NoSQL model with the relational model. And that's not something that the Ethereum software does. It doesn't aim to do that, and it doesn't provide a clear-cut query language for the data store, nor does it provide a concurrency semantics for the access and update of that store. In fact, it's decidedly sequential. And then on top of that, we have architected a model for storage that relates to sharding, so that the economics work out properly. So with Ethereum, storing the data associated with the 3.5-minute song, which is the standard length of a pop song, would cost hundreds of thousands of dollars, if not more. I can't remember the calculation that we did, but it's exorbitant because someone is paying upfront for the data, and what that means is that it's not workable for most kinds of services where whether you're talking about SoundCloud or you're talking about oh gosh, I'm trying to think of the name of it, DistroKid or any of these distribution models. You pay by subscription, right? So it's a pay-as-you-go kind of thing that makes it approachable from the average user, right? Most musicians don't want to pay up front for all of their storage. They want to, and the same is true for virtually all the digital asset management platforms. Imagine if you had to pay up front for all the storage used for all the posts that you did on Facebook. Would you even bother with that platform? Same goes for Instagram. The same goes for all of the digital asset management platforms. The economic model has to match a pay-as-you-go approach, or you just simply will price yourself out of the market for the vast majority of users, right? We're talking billions of users. So it's really, really important to have the economics match the storage, and have the storage match the best practices in terms of what we understand for reliability, so transactions, and for speed, both in terms of the transactional model and in terms of the NoSQL model. So let me stop there and see if what I've said is making sense for folks.
Greg, are you referring to Ethereum 1.0 or 2.0 when you're talking about this, or both?
I'm referring to both, as far as I know. They may eventually get to a rent-like model, but to the best of my knowledge, Ethereum 2.0 does not have a query model for their storage, and that query model is, even if you kind of squint and look at the Solidity as providing some kind of query model, it's decidedly sequential. And the economics of that are still what I said. You pay upfront for your smart contract and data.
Okay, thank you.
Mm-hmm. Any other questions about what I'm talking about?
Yeah, Greg, just like you spoke to the NoSQL, could you speak to the SQL databases which are humongous in the enterprises, and how we would connect to them, or do we have to replace them?
Oh, we don't have to replace them. No. The whole idea is, of course, I mean, the reason we built RChain the way we built it is so that you can get maximum amount of integration with the enterprise. So this goes for the sharding model, so that people can run a private shard inside the enterprise. But it also goes all the way down to the integration with the code. It is perfectly reasonable to have special purpose code that is made available through the interface, the foreign function interface in Rolang, so that if there are dozens and dozens of Java and, in fact, Scala integration with existing SQL stores. And all of that can be made available directly in Rolang. And then, it is possible to outfit that with a cost semantics, which is, the design of our costing model was set up so that we can provide cost accounting for special purpose components. And then, of course, there's a whole issue around trust. So the reason you want to use a blockchain-based storage is that you the parties involved don't trust each other. If you're inside the enterprise firewall, then presumably all of the parties on the inside of the enterprise trust the enterprise's software. Now, this is not always the case in the case of multinational or multi-jurisdictional organizations, which is one of the biggest applications for blockchain inside the enterprise. But we do not have to replace these data stores. We can work side by side, and that's the design and the architecture of RChain was precisely for that purpose. I mean, the whole point is you don't have a viable software product unless you can integrate with the vast majority of software that comes before your platform, right? Most enterprise data, most user data, most government data, all of that is in tech that you didn't invent if you're a newcomer to the field. And so you have to be able to play nicely side by side. And RChain is architected to do exactly that. Does that answer your question, Ron?
Yes, thank you.
Sure. No, it's a really good question. But I just want to see if I'm coming across especially for those people who are non-technologists, if they kind of get, what is the differences for RSpace and Rolang. Again, you need to think of them as a pair. RSpace is not just our storage mechanism, it's also our execution mechanism. So Rolang executes because of the RSpace semantics. So, in that sense, Rolang is next generation SQL. That's the design. That's what we've been following. Essentially, when I had this aha moment when I was thinking about the row calculus, where I suddenly saw the join semantics, and then I saw how it upgraded the SQL semantics perfectly, right? When you have an input meeting an output and you run the COM rule, that is the next version of a SQL transaction. Because it's on the other side of that communication that you have a clear notion of what values are in what variables that have been changed. So that is the transactional point, and that's why we measure COM events as a measure of performance. Because that's like, so when you do these big transactional bake-offs for the different SQL databases, right? The TPCC bake-off, for example, when they measure transactions, they're measuring those kinds of transactions, not financial transactions. So if we want to be, apples to apples comparison with those kinds of data systems, that's what we need to measure. And so our COM event is most lined up with those kinds of benchmarks. And that's why we have adopted the language we've adopted. Does that make sense? Are people following? Maybe a lot of people don't know what the TPCC and the other major database benchmarks are, but it's worthwhile to look up, how databases are measured, how they're, how people gauge their performance, and that's what RSpace and Rolang are targeting. That's the direction that we're targeting. And the big picture reason for that is that we see the market is shifting, right? The market, whether it's the users or the governments, they are not happy with the existing silos of all of this user data and potentially, taxpayer data inside the firewalls of a few companies such as Google and Facebook. That's considered a dangerous trend, and both by the market and by the government agencies. And so if blockchain were able to scale, then it should be about building a giant database. And if you do better, if it's not just a database, but an execution mechanism, then it has, you know, this broad set of user stories or scenarios that you can support. And that's what our architecture supports. So we're basically trying to decentralize the data and decentralize the execution. And the decentralization part is where you say, and we don't trust each other, right? We're running across corporate boundaries or jurisdictional boundaries or other kinds of boundaries. And so there isn't the sort of trust model that is assumed inside the enterprise. And that's where you use blockchain-like storage. Again, let me just check in. I've been talking for a long time. Is this connecting with folks? I don't know.
I would say for myself, being perhaps a non-technologist, some of the semantics is above my head. So I'm having to kind of reach out for certain words that I don't understand and kind of wrap my head around what you're saying. I think I understand it at a certain level, but I don't know what SQL is. I don't know.
Okay.
Yeah. So
that's helpful information. So a long time ago, it was the wild, wild west in terms of how programs store data in persistent storage like disks. And there were hierarchical databases and all kinds of different databases. And then along comes, oh my gosh, now I'm blanking on his name. It's one of the most famous names in computer science.
CJ Date.
What's that?
Are you thinking of CJ Date, the relational algebra guy? Or
Probably. That name isn't the one I was thinking of, but yeah, essentially along comes this wave of computer scientists who say, well, if you use relational algebra, you can structure your data and query your data in this relatively clean way. And it was much cleaner than the kinds of storage mechanisms and ad hoc storage mechanisms that had been, all throughout the industry. And so the vast majority of the industry shifted to relational databases. So, and SQL, abbreviated SQL, is the standard adopted around relational query. So SQL is the query language that is typically associated with a relational database. So when you talk about Microsoft SQL Server, right, or Oracle's SQL Server, those companies are providing large-scale, high-performance relational stores where the standard query language is SQL or SQL. And and that trend was so dominant and so entrenched that there was just lots and lots and lots of performance benchmarks around those ideas. Now there were lots and lots of things which were not answered by that model and that technology base. A really good example is nested transactions, which frequently happen across industrial or enterprise boundaries. So an example that's very common and where I sort of came into the picture as a young mathematician, computer programmer, computer scientist, was the sort of relaxed transactional model that you might find if you were booking a trip. So if you're booking a trip, you need to book your travel, you need to book your where you're going to stay, right? Your digs, and you also need to book your potentially your local transport. This was prior to the days of Uber, so you might rent a car, for example. So all three of those things, they don't necessarily have to go together. So in particular, you might be willing to go ahead and book the trip if you get the flight and you get the car, but you don't get the accommodations you wanted. You might likewise be willing to go if you get the flight and you get the accommodations, but you don't get the rental car. For an example, you could take a taxi, or in this day and age, you could take Uber or Lyft or whatever. So there's this notion of hierarchical transactions or nested transactions or relaxed transactions, where some or all of these things get bundled, and being able to describe how these transactions get connected. It was an interesting research problem. That's in fact where I first saw the significant utility of the process calculi. We were looking at these various relaxed transaction models. We noticed that state machine models were simply completely unwieldy. The exponential growth of the combined state machines were just, that would bring computers to their knees. And even with today's significantly improved compute power, the exponential growth of combined state machines just is simply not feasible, especially since there's a much better solution, which is the process calculi. So they have a way of describing these more relaxed transaction models. And that's exactly what's going on when we give the transactional interpretation of the COM rule. So essentially what I've done is to give you a little bit of a history. I've said what SQL is, where it arose. It comes from something called relational algebra. You don't have to know so much about it, but it's again, this sort of harbinger of correct by construction. The cleanup of query at that time was done in terms of an algebraic model. Now, unfortunately, that algebraic model was not rich enough to describe a lot of what people wanted out of query semantics, but it was rich enough to give significant improvements in usability and implementation. But again, it's this harbinger of what I've been pushing for quite some time, which is correct by construction. And then the revision, one way to think about that the process calculi are in fact the next generation of the SQL model and a reconciliation of the NoSQL model is Abramsky has given an extremely nice account of process algebras in terms of relations extended in time. So it's literally a kind of relational algebra that's extended to include a notion of temporal evolution. So this is some not insignificant mathematical evidence that it is in fact the next generation of relational model. And then the fact that in our space, the way we implement this relations extended in time is in terms of a key value storage that allows us. So the keys are the names in Rolang, and the values are either data or continuations. And the continuations are, of course, the evolution in time of the program. So that's how to see in a more granular form how the Rolang R-space model really is at the details a reconciliation and refinement of both the NoSQL approach and the SQL approach. Maybe that was too much, Daryl, but did that help at all?
No, I think, yeah, actually it helped a lot. I'm starting to get a little, the wall is starting to get pierced a little bit in my understanding of things. So Thanks for that.
Sure. No, I really appreciate the opportunity to talk about this stuff. I don't actually talk about it very much. I mean, it was a major part of my focus when I was trying to push Special K, which was my third iteration implementation of these ideas, with the Microsoft BizTalk being the first. At that time, so around 2010 or so, we could, the pitch was something like, Special K, or this kind of approach to storage is a direct competitor to SAP HANA. And that's something that Ravi picked up on when he joined RChain for the time that he did. It's like he realized, okay, this is SAP HANA on steroids. So SAP HANA is SAP, as you may know, is one of the major data storage and business process providers in the enterprise. And they sort of picked up on an improvement on the NoSQL approach. And you could think of Rolang in RSpace as a direct competitor and significant improvement on SAP HANA. But what makes it not a direct competitor is that we just don't go after the inside of the enterprise with that kind of focus. Instead, we implement the consensus algorithm that allows these data storage mechanisms to be connected in a way that they don't have to trust each other. So that's another differentiating feature for us from SAP HANA. So hopefully I've discharged my obligation to talk about in a manner that's relatively accessible what distinguishes the Rolang RSpace technology from Ethereum, but also from the rest of the various offerings. And I've tried to place it in an economic context, right? So the economic context that we're considering is one in which both the market and the governments are very uncomfortable with the centralization of user data. And there has to be a solution whereby user data is essentially managed by the people rather than managed by private corporations. And blockchain provides that kind of solution if and only if it scales. And we offer an architecture that we know will scale. Okay, so hopefully that that provides some insight for folks. There's a discussion of all of this in the prospectus under the technology section. So we take it in terms of RSpace and then Rolang, and then Casper, and then with a brief mention of the communications layer. So all of those different pieces are discussed, and how they're related to each other is discussed, and how that relates to the intended market is discussed. And hopefully it should be crystal clear from that documentation how this is different from Ethereum and the other solutions in the space currently. Any other questions or comments before we yield the time back?
I have one question, just since we're talking about Ethereum. I've been wondering about just the whole proof model, proof of stake. There is some criticism out there against it, and I'm just kind of wondering whether, to what degree, and this is exposing my lack of knowledge probably, but to what degree what you've been talking about is dependent on Casper and proof of stake in general, or whether another proof could be used down the road with, you have Bram Cohen talking, that's his name, Bram Cohen, talking about proof of time and space and other methods. Is proof of stake truly the one? That's my question.
Okay, so I want to hang on one second. I just want to clue my son in that he needs to turn things down. One second. Okay, so I've spoken to this many times, and so I'm happy to review it. But exactly this theme is what's taken up in the prospectus, so that people can understand how the pieces of technology fit together. And that is also discussed at length in the presentation. Hang on a second, let me just find it here. There it is, staring me right in the face. Oh, I see. I didn't put it in here. Okay, I'll have to put it in the folder so that people can get a hold of it. But the presentation that I gave in the roadshow in China. Oh wait, no, here it is, right here. So I kind of give a thumbnail sketch of all of this. So let me speak to this. I'll do a screen share. Okay, so hopefully people can. Oh, what happened there? Okay, so our position has been build something that's big enough to be a digital asset management system for the entire globe, and then put, add in payments as a side idea, as opposed to building a payment network and trying to make a digital asset management on top of that. That latter approach is simply not workable. So what that means is if you're actually going to build a digital asset management system, your focus is going to be storage. You've got to have a scalable storage asset. And so scalable storage asset means a lot of things. In particular, it means you have a notion of transaction. That notion of transaction is rich enough to include these sort of more relaxed transactional models, so that you can pump, you can push the performance and not get. I mean, the biggest problem with the two-phase commit, which is the protocol associated with relational databases, is it's basically the unavailability protocol. Everything is locked down until the transaction goes. All of the tuning of those kinds of databases has to do with figuring out what's in the transaction and what's not in the transaction. Here we have this the Rolang model and the RSpace model gives you this incredibly fine-grained locking mechanism on the transactions. Like the transaction can just be on one particular key in this giant key value store. So you can think of that as one item in a row column gadget, one item in a table. So we have basically item level locking that falls out of the Rolang model. So that means you can tune your transactions to a very, very fine degree, right? That's not offered easily in the relational models. And then on top of that, you have to have a query mechanism that works with that transactional model and that has to support concurrency. So Rolang RSpace answers all those questions, and that is completely independent of the consensus model or the comms model. So you can roll out an instance of Rolang and RSpace just for your storage solution inside an enterprise. So it has nothing whatsoever to do with, so this is our node 0, right? If you look at our release map, our node 0 is Rolang plus RSpace, right? The instance doesn't, the node doesn't talk to other nodes. It provides a storage and execution mechanism, right? So that's how you think of the architecture as factoring. And the rationale for that factoring of the architecture has to do with how we're viewing the market. All right, so now that you've built a good storage mechanism, now you want to have multiple instances of these storage mechanisms talking to each other. So that's effectively what the comms layer provides for nodes. So our node 1, you now have different nodes talking to each other. But there's nothing in the way of consensus. So there's no, so that's basically just, I've got a database over here that's dealing with my customers in Seattle, and I've got another database over here that's dealing with my customers in Portland, and I can potentially look at queries that deal with folks in Seattle and Portland, right? Or I can deal with processes that involve folks in Seattle and Portland, but there's nothing in the way of consensus on overlapping data, right? So if you put overlapping data there, then you're on your own in terms of how those transactions are going to maintain any kind of consistency. So they're just, our node 1 is the nodes are talking to each other. Now, the next piece of the puzzle is to our node 2. Now you put Casper on top of that communications layer so that these instances can have overlapping data, right? So they can have common data across each of the different nodes. And Casper will make sure that they agree on the data. And the way it does that, the only job Casper has to do in terms of consensus for Rolang is to make sure that all the nodes agree on the races. If they all agree on, so by races, there's, if you have a for comprehension, so this is code that is waiting on some data at a particular key in the key value store. And there are 2 data providers that are running to put code at that key, to put data at that key, then one of them will win. And as long as all nodes agree on the winners of all the races, then their view of the data will be exactly the same. And so that's what allows you to have overlapping data and data consistency. But now the problem with that model, if you were just to take that piece, right? So again, you've got a storage mechanism and a communication mechanism, and then on top of that communication mechanism, you put some kind of consensus. We don't care what kind of consensus it is. We just need the consensus to create, to say what, who the winners of the race are. So we're at 11:58. To complete this discussion, I'm going to run over. For those people, I just want to let people know, for those who are, have other time commitments, they might want to jump off now. Otherwise, I'm just going to keep going until I've answered Daryl's question. So we've got, a storage mechanism, we've got a communications mechanism between them, and then we've got a consensus mechanism on top. Each of these components are swappable in the RChain architecture. You could swap out different components and have them do replace them with better versions. And I'll say why you might want to do that in a minute. But the problem with that is if you put that out in the wild, like if you deploy that inside the enterprise, that's a very decent solution, right? You now have a distributed fault-tolerant data store, right? So you could run that storage inside the enterprise, and it would provide, good coverage of enterprise problems that cross jurisdictions inside the enterprise. So NCR Japan with NCR UK, for example. Those two entities could use this storage mechanism to do data integration across the two different jurisdictions. And that's because we know that NCR Japan is not going to launch a denial of service attack against NCR UK because they're all part of the same company or family of companies. But if you were to deploy this in the internet, now you have all kinds of actors out there who can potentially attack the system, who are not necessarily in alignment with the good use of the system. So to prevent the denial of service attack, you have to add a cost model so that to compute any Rolang or to store anything on the chain is going to cost you something. And this is just like the kinds of APIs that have been internet facing for the last 20 plus years, right? If you go to Google or the Google services, you have to get a usage token in order to call their APIs. And these kinds of tokenizations of access to a particular API have been, around long before there was a notion of blockchain. It's just that with blockchain and the idea of tokenizing it, you can now get crisp accounting of the usage of the API. So with Amazon, you still have to trust them when they report to you that you've used so much storage and you've used so much compute cycles. With this approach, where you instrument the execution in terms of the token, that this is a completely objective measure. Everyone can agree on the costs, and then you can build a market around that. So with the cost accounting, that's the last feature. That's node 3. So we went, node 1, node 2, node 3, and then you also use the token to secure the validators who are implementing Casper and making sure that all the races, all the nodes agree on the winners of the race. Okay, so that's a quick overview of all the major components and how they fit together. And, with an emphasis on the fact that each of these components are modular with respect to each other. Does that make sense, Daryl?
Yeah, that was amazing. Just the last thing you said, I know we're running over time, but the last thing you said about how, and then the tokens, you're talking about how the tokens go back to Casper somehow. Can you just explain that last little bit? Because that kind of threw me off.
Yes, that's so the tokens are also used. This is what the validators stake with. So they stake with tokens, and a validator can only play the validation game as long as it has stake in the game.
Oh, okay, yeah, okay. I thought you were talking about something more complicated there, but okay.
Well, it is more complicated than the original conceptions of, so a lot of stake grinding and other issues with respect to proof of stake are addressed when you have slashing. Sorry, my puppy wants to go play again. No, we're not going to play right now. Sorry. Sorry, Fiber. No, not going to play right now. Nope. No, we're not going to play. Okay, so now let's talk about how we might improve this architecture. So one place where we want to improve the architecture is all the way back at the beginning. All right, so back at the beginning, we talked about making a scalable storage and execution mechanism. Well, one way to make a scalable storage and execution mechanism is to put all of the execution mechanism in hardware. So we have a design for that, right? And we have numbers that are based upon work that I did with Satnam Singh, who was the chief hardware engineer for Xilinx, who was the major provider for FPGAs, field programmable gate arrays. So Satnam Singh and Jan Gray and Alan Brown and I did a pi calculus chip. And then I refined that model for row calculus. And I came up actually with two different designs. One of them is checked into the repo, Akbar's grasp, that people can take a look at. But that should give us factor of 1,000, and in some cases factor of 10,000 improvement on row-lang execution. And then we can connect that directly to these more recent NVMe storage models to get significant improvements on the storage and execution. So that would replace the JVM-based architecture that we've got, right? And then so that obviously there's a lot of stuff that has to take place in order for that to become commercially viable, right? But there's a how do I say it? It's a relatively straightforward engineering. I mean, there's I mean, how do I say it? The risk in realizing something like that is, you know, mostly just market contingencies and, you know, resource planning and those kinds of things. It's effectively a no-brainer. There's no rocket science in doing that at all. It's just, you know, I mean, I'm actually shocked that we should be able to raise funding for that, like, in a heartbeat. So that's one place where we want to improve. You know, I'm not going to talk so much about the comms because right now nothing's going to move the communications layers of the internet very much. But there is a place where we could also improve, and that's in consensus. And so what I've been saying for quite some time now is that if you go look at the quantum computation literature, one of my colleagues, Prakash Panangattan, published a paper over a decade ago now, in which he described the use of particular quantum state, just leave it at that. A particular quantum state for doing leader election style distributed consensus. Now that idea has been significantly improved, and I sketched out an approach to using quantum computation just for the problem of consensus. Now, so lots of risks there, right? So I spoke to Bob Kuka, who is one of the premier quantum computation researchers at Oxford. He agrees that the approach seems viable. He thinks he can get it done using a formalism that he developed called the ZX calculus. And he believes that he can realize it in hardware with a partner that he has in Cambridge that is doing some quantum compute hardware. So this is very, very different than the use of quantum compute for cryptography or quantum compute for general purpose stuff. It is one purpose, which is to get enough information to decide the winners of the races across all of these different nodes. And the commercial model is in order to stake, you have to buy some material which has been specially prepared so that you have entangled pairs. And as you run through the consensus protocol, you are essentially using up the material. So your stake degrades in a natural way over time. So that's the kind of commercial model that I'm imagining. So this has all kinds of advantages, right? Because it will force the rollover of validators, right? And so a lot of the coordination is just in the distribution of the material, right? Once the validator has the material and it's wired into their hardware in a particular way, then the consensus effectively takes no time. So we've dropped it from being one of the major contributors of time in the overall execution of RChain to 0 time, right? So our overall performance has gone through the roof. And now the question is, why do we want to have that kind of performance? And the answer is very obvious. If we want to decentralize these massive data silos of user data, all you have to do, no, not right now, puppy. No, I'm not going to do it right now. Nope, I just took you out. You guys should see her. She tilts her head when I'm talking to her as if she's trying to understand what I'm saying. All right, so just to finish this up, if you were going to have a decentralized data Facebook, here's the numbers you have to deal with. Facebook has over 1 billion users. Each of those users has a feed that's over 100,000 posts deep. Each of those posts needs to correspond to a smart contract. So we're talking 100 trillion concurrent smart contracts all running. There is not an architecture on the planet. I mean, Ethereum 2.0, Ethereum 10.0 hasn't contemplated an architecture that can support 100 trillion smart contracts all running at the same time. I mean, heck, even with Ethereum 2.0, they are looking at, they still don't even scale, right? Yeah. Like as you add more nodes, they get slower. So they're nowhere near contemplating what it's going to take to decentralize these data silos in an effective manner. So the kinds of architectures that I'm describing are aimed at actually really doing that. You know, so that's hopefully that gives you an answer that's complete, and you see how all the pieces fit together, and you know, I mean, your question was just, are we dependent on Casper? Is proof of stake the only thing that we? No, absolutely not. The architecture is modular. We can swap out the consensus. And here's a crazy, wild-eyed idea for the kind of consensus that we want to go after. But there you go. That's my answer.
Okay, thank you.
Sure. So we're way over. Any other questions or comments before we stop? Okay. Thanks to all. I hope everyone stays safe, and we'll talk again next week.